So let us try to understand about the Cannizzarro's reaction, which is also known as the disproportionation reaction. In this Cannizzarro's reaction or the disproportionation reaction, what happens basically, the compounds having the no alpha hydrogen atom. If you look at the formaldehyde, here it has no alpha hydrogen atom, because initially that I had said to you that if acetaldehyde is taken, this is the functional group, and when the functional group is attached to, when a carbon is attached to that functional group, that carbon is alpha carbon, and when hydrogens are attached to that alpha carbon, those hydrogens are called the alpha hydrogens. But if you look at this compound, here the alpha hydrogen is not there. So formaldehyde, here formaldehyde refers to, functional group CHO is there, but alpha carbon is not there. That's why the formaldehyde is basically not an alpha. Here in the formaldehyde, alpha hydrogen atom is not there. Similarly, in the benzaldehyde also, the alpha hydrogen atom is not there. So Cannizzarro's reaction takes place in those compounds which do not possess alpha hydrogen atom. First point that you need to remember. So here I have taken the formaldehyde. When the formaldehyde reacts with NaOH, and here we need to remember, in case of the aldol condensation, then dilute NaOH is required. But in case of Cannizzarro's reaction, the concentrated NaOH is required. So formaldehyde reacts with NaOH, and finally it gives HCOONa, that is sodium formate, along with the methyl alcohol. Similarly, if you look at the benzaldehyde is also a compound which do not possess the alpha hydrogen atom. So when benzaldehyde reacts with sodium hydroxide, concentrated sodium hydroxide, here look at here what is obtained basically here, 1, 2, that means 2, 2, so 2, 2 dimethyl. In second position, both the methyl groups are obtained, so 2, 2 dimethyl, 1, 2, 3, that is 2, 2 dimethyl sodium propanoate. So that's what you need to mention, 2, 2 dimethyl sodium propanoate. How the name has been obtained? First of all, the substituents in second position methyl groups are attached. So how many methyl groups? Two methyl groups are attached. That means 2, 2 dimethyl sodium, 1, 2, 3 carbons are there, so sodium propanoate. So this is what the name of the compound, and here it is 1, 2, so 2, 2 dimethyl, 1, 2, 3, that is 2, 2 dimethyl propanol. Propanol. Why? Because alcohol group is attached there. Well, here in Cannizzarro's reactions, anyhow the alcohols are obtained. But what is the mechanism of the mechanism of the reaction? The mechanism of the reaction is that, suppose I have formaldehyde. When the formaldehyde reacts with sodium hydroxide it possesses the OH minus. So the formaldehyde here it reacts with OH minus. And you know that, you see here the pair of the electron, the shared pair of the electron will be attracted more towards itself since the oxygen atom is highly electronegative than that of carbon atom. And finally it obtains Hc. Since the shared pair of the electrons are attracted towards itself, that's why there is a formation of the negative charge. And the product here which is obtained, the reaction is reversible as well as it is fast reaction. The product which is obtained, that product reacts with the formaldehyde again. Here what happened? The hydride transfer takes place. That means the hydrogen which is attached to this carbon atom now will attach to this carbon atom, and finally it forms here. And since the shared pair of since the oxygen is more electronegative than that of carbon, so the shared pair of the electron will be attracted more towards the oxygen atom, and finally it gives the O minus. And in this way the hydride transfer takes place. Again what happened? The hydride transfer as well as HCOOH, that is formic acid is obtained, and here in the formic acid again the proton basically transfer. That means this shared pair of the electron will be attracted more towards the oxygen atom, which is a highly electron negative. And the hydrogen atom, yes, the hydrogen atom which is there, and here this oxygen atom attracts that hydrogen atom finally. That means the proton transfer takes place, and finally it gives the CH3OH, that is methyl alcohol, and HCOO minus, that is formate. So this is the mechanism of the Cannizzarro's reaction. So what is Cannizzarro's reaction means? What do you say? That the Cannizzarro's reaction takes place in those aldehydes which do not possess the alpha hydrogen atom. So here you need to remember both the concentrated alkali are important to be utilized as the required reagent. And in the crossed Cannizzarro's reaction, the benzaldehyde reacts with the formaldehyde to give, the benzyl alcohol along with the sodium formate. That is what the crossed Cannizzarro's reaction. I hope you understood the Cannizzarro's reaction as well as the crossed Cannizzarro's along with the mechanism of the Cannizzarro's reaction. And this is very much important for the examination. I hope you remember this one. Well, this is all about Cannizzarro's reaction. And now we will discuss the next chemical reactions of this chapter. Here now we will discuss, the haloform reaction. That is also very much important, for the examination. But before that, let us try to discuss the difference between aldol condensation and Cannizzarro's reaction. Aldol condensation, let me just abbreviate as AC, and Cannizzarro's reaction, let me abbreviate as CR. So what is the difference between this aldol condensation and Cannizzarro's reaction? In aldol condensation, at least one alpha hydrogen atom is required. At least one alpha hydrogen atom is required. But in Cannizzarro's reaction, no alpha hydrogen atom is required. That's the point, that first point that you need to remember. The second important point that you need to remember is that here the aldol condensation takes place and it occurs in the presence of the dilute alkali. But in Cannizzarro's reaction, it occurs in the presence of concentrated alkali. Similarly, the third point here we need to remember, the reaction, it takes place, the reaction proceeds through carbanion. But this reaction proceeds through proton transfer. So these three important points that you need to remember in which the difference between aldol condensation and Cannizzarro's reaction. Let me repeat it once more. In aldol condensation, at least one alpha hydrogen atom is required. On the other hand, in Cannizzarro's reaction, no alpha hydrogen atom is required. Point 2. In aldol condensation, the aldol condensation takes place in the presence of dilute alkali, but the Cannizzarro's reaction takes place in the presence of concentrated alkali. And this reaction proceeds through the carbanion. On the other hand, the Cannizzarro's reaction proceeds through the proton transfer. And that's the difference between aldol condensation and Cannizzarro's reaction. I hope it is very clear to you. Now we will discuss the haloform reaction. So what is this haloform reaction? In this haloform reaction, the acetaldehydes as well as the methyl ketones, they react together, in the presence of the iodine and the sodium hydroxide to form the iodoform, which is a yellow precipitate. Since the iodoform is formed, that's why this reaction is also a haloform reaction. That means it reacts with, in the presence of chlorine, bromine, iodine, etc. Look at here. Here we have sodium hydroxide NaOH. When the sodium hydroxide reacts with iodine, then sodium oxyiodide is obtained, that is NaOI, with sodium iodide along with water molecule. Then the sodium IO, that is NaIO, this NaIO reacts again with acetaldehyde in the presence of I2 or NaOH, that means iodine or sodium hydroxide. Then it gives this product, that is I3C bond CHO along with 3 sodium hydroxide is obtained. Look at here, the product which is obtained here, that product reacts with sodium hydroxide. And on reaction with sodium hydroxide, HCOONA, that is sodium formate, is removed from here, and CH3I, which is the methyl iodide, it's a iodoform which is yellow in color, and this is basically a precipitate in nature. But we need to understand here the mechanism of this haloform reaction. That's what very important. If you look at the mechanism, we have sodium hydroxide. When it reacts with I2, Here NaOI, NaI and water is obtained, no doubt. But this NaOI, if it is on dissociation, it gives NaO, that is sodium oxide and iodine ion. Look at here, I have taken acetaldehyde, that is CH3CHO, that means H bond CH2CHO, acetaldehyde. When this acetaldehyde reacts with alkali, then water is removed from here and finally it gives CH2CHO. This is H plus and OH minus, it reacts together and finally it gives water, the water is eliminated and finally it gives a nucleophile. A nucleophile is obtained with iodine ion. And again the nucleophile reacts with the iodine to give ICH2CHO. The iodine is attached to the compound. And in the next process what happened? You see, and in the next reaction as well the water elimination takes place. That means this H plus, it reacts with the OH minus and water is removed from here and finally it gives CiO and a nucleophile is again obtained. And on dissociation that it gives I2CHCHO. And what the I2CHCHO, this is what here it is obtained, I2CHCHO, it again treats with hydroxide ion, that is OH minus ion, with the elimination of the water molecule, and it gives the Ci2CHO because water molecule is eliminated and the iodine, and finally the product is obtained, that is I3C single bond CHO. But here it is not stopped. Look at here I3C CHO, I3CHO, and if again it reads with OH minus ion, this OH, that means the oxygen atom, the hydroxide ion, it attacks with the carbon atom, and here the shared pair of the electron will be attracted by the oxygen atom, and finally a negative charge is created in oxygen atom. And here since the hydroxide ion is attached to this carbon atom, that's why a sigma bond is formed. And further what happens here, I3C minus is obtained, so that means a iodoform. This is what basically called the iodoform. So iodoform is finally here it is obtained, that is I3CH. So I3 CH3I. So this is basically this is basically what CH3I. But when the CH3I is obtained, when that acetaldehyde reacts with NaIO, and in this way the iodoform is obtained. So the mechanism of the iodoform, it takes such a long distances and it takes such a long procedure. But anyhow, we need to understand the mechanism of this iodoform reaction. And most importantly, in iodoform reaction, what is formed here means, what do you say, that a yellow precipitate, that is the iodoform, methyl iodide, a yellow precipitate is obtained. And that's what all about the haloform reaction. Here we have discussed both the aldol condensation and difference between aldol condensation and Cannizzarro's reaction, and also we have discussed the haloform reaction along with its mechanism. So this is all about the aldehydes, the ketones, as well as its various chemical reactions. And this is what here we have completed the aldehydes and ketones portion. And in this unit we have one more portion, that is the carboxylic acids. And in the next video lecture, that we will decide the carboxylic acids, the methods of preparation, the physical properties as well as the chemical properties in a very detailed and the systematic manner, so that you understand each and every reaction very carefully. And if you would like to watch the next chemical reaction, I request you to press the bell icon over here to get the latest notification. Thank you very much for watching.